This is an example of a linear programming problem. There's a lot of information going on in this video, so I'm going to try to break it down with different colors. So here's what they give you first. They say a bakery has two types of bread, bread A and bread B. Those are going to be what we call our variables. Then within batch A, we use 5 pounds of oats and 3 pounds of flour. In batch B, we use 2 pounds of oats and 3 pounds of flour. Those are going to be your restrictions. And then we can have a total of 180 pounds of oats and 135 pounds of flour. So step 1, we want to define the variables. There are 2 variables. How many loaves of batch bread A, and then how many for batch bread B do we want? So those are your X's and your Y's. Then step 2 is to identify your constraints or your inequalities. These describe the constraints. The first 2 are pretty easy. You can't have a negative amount of batches. So you're going to have an X greater than or equal to 0 and a Y greater than or equal to 0. The last 2 constraints I've color-coded back up in our word problem in the teal and the purple. So let's talk about the purple here. So in the purple, we have 2 pounds and 5 pounds and 180 pounds. So 5 pounds plus 2 pounds can be no more than 180 pounds of oats. So that's representing this constraint right here. 5x plus 2y can be no more than 180. Then in the teal that I've highlighted here, 3 pounds and 3 pounds of flour can be no more than 135 pounds of flour. So 3 pounds of batch A plus 3 pounds of batch B can be no more than 135 pounds of our flour. That's our last constraint. So these are the 4 constraints that we're going to graph on the next slide. I've made it easy for you to just look at the graph already completed. You'll have to do this on your own. You'll have to graph the resulting inequalities. So what we would have to do is we'd have to convert all of these to slope-intercept form and then find out where they intercept. Let's focus on the graph instead. So the first thing we want to notice is what we call the feasible region, where it overlaps. So that's everything in the yellow here. Then we have some corners. We have a corner at 0, 0. We have a corner at 0, 45. Where they intersect of a corner of 30, 15, and then 36, 0. These 4 points are what we call our corners. And what we're going to do is we're going to plug them into our objective function. That's leading us to this. More information about the bakery. The bakery wants to maximize its profit. So remember, we said it would be either maximum or minimum. In this case, we want the maximum profit. One batch of A yields a $40 profit, while batch B yields a profit of $30. How many batches of each should they make? So in part 5, we have our objective equation that we want to, in this case, maximize. And we're going to let P equal our profit for the bread. And then we have our equation. P equals $40 times X plus $30 times Y. Give you some time to take that in. Make sure you get your pies in if you need to. So we've just done step 5. Step 6 is to substitute those corners into your equation. So this is your profit equation here. P equals 40X plus 30Y. And you're going to take these 4 corners that we found here in the purple. Again, 0, 45, 0, 0, 30, 15, 36, 0. And we're going to substitute them in for X. So this is my X, My X goes in here. This is my Y goes into here. When I get out, I get a profit of no money because I haven't made anything. Then substitute 0 in for X and 45 in for Y. When you multiply those numbers and add them, you get 1350. And you would continue doing that for the next two corners. Notice the one that has the largest value. This is our maximum profit. So we want to choose 30 batches of A and 15 batches of B to give us a profit of 1650. And that's what we're going to finish up, step 7. We're going to pick the maximum or the highest, which is at vertex 3015, with a profit of 1650. So here's the end. Alexis Bakery should make 30 batches of bread A and 15 batches of bread B to maximize the amount of profit. We will be doing one of these in our warm-up, but I do want you to be familiar with what linear programming is and what the 7 steps are. You don't have to be an expert at this point, but I would like you to be prepared for tomorrow when we do our warm-up.